power. Engineers have been on a continuing search for the most efficient and reliable means of power shaft drives and connections. One of the first approaches used was a simple pin connection. Although this continues to be a reliable method for certain safety-related or low-cost applications, it was discovered that the pin method was very susceptible to shearing due to concentrated stress forces. Another approach used was the key. This too remains a very useful method, but it also does not reliably hold up to high stress or high torque loads. It was subsequently determined that if the load could be distributed over a greater surface area of the shaft, the connection would be much stronger. At this point, the splined shaft was introduced. Spline shaft connections continue to be useful, but only for relatively light loads. Engineers quickly realized that there are some inherent problems with the spline. There is a backlash problem. Typically, only 20% of the teeth actually contact, causing the teeth to flex, reducing load capacities and concentrating stress, which in turn caused shearing problems. These problems are somewhat overcome by increasing the diameter or length of the splined shaft, but this introduces space and weight problems, which can also increase cost. Shaft alignment is also difficult, which often results in machine failure, along with high repair costs and lost production. The next step was involuted splines. Although this new profile increases the contacted surface area, many of the problems with standard splines also plague the involuted spline configuration. Surface area contact was greatly increased with the introduction of the serrated shaft. This design substantially reduces the stress concentrations and increases the contact surface. But it too has load limitations and space, weight, and maintenance problems. The ideal solution is to substantially increase surface contact area and to remove stress concentration points altogether. Such a design would eliminate concentrated stress, backlash, and shearing problems while increasing load capacities. Machines could be designed to be more efficient and much more reliable. General Polygon Systems Incorporated is offering such a system. The General Polygon system is designed to eliminate common failure problems associated with spline and key shaft attachments. The General Polygon system is a proven, superior method for making demanding mechanical connections that are much stronger, much more precise, and have a substantially longer service life. The Polygon system allows the shaft to be shortened and the diameter made smaller, resulting in lighter, more compact equipment. It also reduces overall costs, increases load ratings, makes for faster, more simplified assembly, and significantly reduces machine downtime. The high-precision, highly reproducible profiles of the Polygon system provide connections that have perfect symmetry and concentricity. Polygon connections have twice the shear strength of comparable size splines, resulting in a 35% greater torque capacity. Effective load distribution virtually eliminates point contact, minimizing stress fatigue, distortion, and shearing, extending the service life of the coupling. Polygon connections are fully self-centering and self-aligning. The attachment of the component to the shaft can easily be accomplished by simply slipping it into place and applying a snap ring, reducing machine downtime and maintenance costs. Polygon contours also fit better. Interchangeable mating surfaces are finished to high precision tolerances that result in very close fits. Shafts and bores can be ground to plus or minus 2/10,000ths of an inch on a 1-inch diameter and plus or minus 5/10,000ths of an inch on a 5-inch diameter, with a profile accuracy of plus or minus 3/10,000ths of an inch. The configurations and profiles of the Polygon system expand engineering and design capabilities because of its reduced space and assembly requirements. The high-precision Polygon systems are kinetically produced on Fortuna polygon grinders by General Polygon Systems Incorporated. General Polygon Systems Incorporated is the largest contract machining service for polygon connections in the world and has the capability to produce quantities from a single prototype to high production runs. Polygon profiles are available through General Polygon Systems Incorporated in standard P3 and PC4 profiles, or modified with custom profiles for special application requirements. The P3 profile is ideal for non-sliding connections and tapered connections. The PC4 polygon can be used on either sliding or non-sliding connections. General Polygon Systems Incorporated. Advanced mechanical connections for your demanding high-speed power and motion transmission applications.